Welcome back. Let's begin talking about integers. Okay, so we talked about there's several types of numbers, number objects in Python. Integers is the first type. So integer, that type models whole numbers like 1, 2, 3, 0, negative 737, etc. Okay, something without a decimal point. And in order to start looking at what we can do with integers, let's look at some expressions and the read, evaluate, print loop, or REPL loop. And to do that, we're going to follow along with session 1.1 from your text. Now, if you look on Canvas in Module 1, you'll find that there is a Jupyter notebook for you to use here. So if I upload that Jupyter notebook into Drive, I've just uploaded that file, and then right-click, open with, that'll open that file up in Google Colab. And in here, in this notebook, you'll find all of the code, sample code from Chapter 1 already pre-entered for you, right? So you don't have to do a lot of typing. And you certainly can type those up yourself if you want to, but you can use this code to follow along if you would like. Okay, so we're looking at sample or session 1, simple integer math. And what we have in the first code cell then is adding two integers. So we're going to be treating Python sort of like a calculator here. I just say 2 plus 2. And if I want Python to evaluate that, I can either click the run cell, or I can do Control Enter at the same time. So I'm just going to do Control Enter. Since it's the first cell I'm running, it takes a while to establish that resource out on Google's cloud servers. And then, boom, 4. It gives you my answer. Okay? And then if I go to my next one, I can do subtraction. So 100 minus 75 is 25. 7 times 9 should be 63. And now we get into some division ones, okay? And so we're going to pause our discussion here about simple integer math and pop back to the presentation for just a second to look at those special cases. So we have two different types of division in Python. A single / is floating point division, and 2 slashes is integer division. Okay, and we'll take a look at that here in a second. Then we also have another symbol, the percent sign in programming is used to get the remainder after an integer division, and that's called a modulo operator. So we'll look at those here in a second, and then we'll start looking at our order of operations in session 1.2. So here we go. Let's talk about division. 14//2, that's integer division, so I should see 7, okay? But if I do 15//2, now it's integer division, so instead of 14.5, or 7.5 rather, I'll get just 7, okay? So when I do integer division, any fractional part is just discarded. We truncate it, we get rid of it. If I want to know how many are left over in a division, then I can use the modulo operator, which is that percent sign. So 15 mod 2 is 1. Okay, so that's the remainder after dividing 15 by 2. Okay, and that's actually a handy way to determine if a number is even or not. Is if I look with the modulo and it's a 1, it was an odd number to begin with. If I get a 0, it was an even number. Now let's take a look at our order of operations. So order of operations in session 1.2, this follows exactly what you've learned before. That is that multiplication comes first, then addition. Division would come first, then subtraction. So in this situation, I should have 12 times 6 plus 2, okay, which should be 74. In this situation, rather than reading from left to right strictly, it would see that the multiplication should come first. So it's still going to do the 12 times 6 first and then add 2. So that's a 74. Okay. If I want to override that priority, then I can do that with parentheses. So now I'm saying do the 2 plus 12 first, gives me 14 times 6, which should be 84. Okay, and now 12 times 6 plus 2, this will say 12 times 8, which should be 96. Okay, and then we also have the ability to do exponentiation in Python, and we do that with 2 asterisks. So this would be 2 to the 3rd power, or 8. All right, so those are our order of operations. And now what we'll do in our next video is start talking about floating point operators, and floating point numbers rather, and the expressions we can do with them.